Hello, welcome to my video series about how protein powders are made. This one will focus on pea protein versus pumpkin seed protein. I'm here to empower you in taking control of your health. Knowledge, when properly applied, is power. Protein has many vital functions in the body, although most people merely think of it as being involved in the healing process or in building muscle. I've done an entire video series to help illustrate the many benefits and functions of protein. So if you'd like to learn more, go to my YouTube channel, Dr. Max McLeod. Although our protein needs are not huge, they are significant, and generally more than the government recommendations. Most people don't realize that the government guidelines were never meant to be recommendations for optimum health. They're more geared toward keeping people reasonably healthy and functional, in other words, able to work and perform their various jobs and activities of daily living. For many people, taking supplemental protein in the form of powders has become commonplace. As with anything, there's a wide range in quality among various products and types of protein powders. This video series is meant to help you address and explain the way protein powders are made. The information will help you to make more informed choices about protein powders. First off, it's well established and agreed upon that food-based proteins are generally the best in terms of both quality and usability. On this point, I'm in complete agreement. That doesn't mean that one should never use protein powders, as they do, in fact, serve an important role in many situations. I personally use protein powder as at least one meal every single day, and I have for many years. In this video, I'll focus on the production of pea protein and contrast it with how we produce our pumpkin seed protein. Pea protein has gotten quite popular over the past few years and has become the go-to plant-based protein for many companies and individuals. Pumpkin seed protein, on the other hand, although little known, is, however, in my opinion, the absolute best choice currently available. That's why it will be used as the comparison protein throughout this series. Full disclosure and notification, I am biased in that I have developed several pumpkin seed protein products. The reason that I developed and manufacture pumpkin seed protein products is because my research led me to the clear conclusion that it is the best. This is just a quick look at what we'll be going over in more detail in this video. I previously developed and formulated products using whey protein, both concentrate, isolate, and hydrolyzed, rice protein, hemp protein, egg white protein, pea protein, and even fish collagen protein. After discovering, working with, and studying pumpkin seed protein, I gradually discontinued all the other formulations over the course of several months. I just couldn't justify using them when I had pumpkin seed protein to work with, even though pumpkin seed protein was more costly to use than any of the others, including premium whey. That being said, let's dive into this. First, I'll discuss how pea protein is produced. The peas used to make pea protein are not the peas most people think of when the word peas is mentioned. They use yellow peas. The following quote comes from the Journal of Agricultural Food Chemistry 2001 paper titled Production Process for High-Quality Pea Protein Isolate with Low Content of Oligosaccharides and Phytate. It states, pea as well as other legumes contain a variety of anti-nutritional and anti-physiological factors which negatively influence the quality of the proteins. It is therefore of great importance to develop a production process resulting in a pea isolate devoid of the anti-nutritional and anti-physiological factors. Here we go. Step 1. Yellow peas are dried, dehulled, and milled into pea flour. Step 2. Water is added at a concentration of 11 to 13% flour to 87 to 89% water. Step 3. Sodium hydroxide is then added to adjust the pH, or the acid-alkaline balance, to 7.3. Sodium hydroxide is also known as lye or caustic soda. It has numerous industrial applications. Here's some important uses of sodium hydroxide. Note, sodium hydroxide, also known as lye or caustic soda, is an inorganic compound that's typically used in a variety of ways. For example, the making of soap, decomposition of proteins in animal carcasses, in drain decloggers, and oven cleaners. Note that it decomposes proteins. Now, I'm not saying that sodium hydroxide is necessarily dangerous or harmful. It may be and it may not be. But I am saying that it decomposes and degrades proteins. and we just happen to be talking about proteins. Step 4. The extraction of soluble proteins is then performed by removing the non-soluble carbohydrates and fibers via a continuous centrifuge decantation process. This is a generic diagram showing what a continuous centrifuge decantation process looks like. As you can see, there's quite a bit going on there. Step 5. Clarification treatment that removes soluble fiber and residual starch. Somewhat of a poorly detailed clarification treatment to remove the soluble fiber and residual starch. Again, this is a generic diagram showing that process. Pasteurization is step 6 at 72 degrees centigrade, which is 161 degrees Fahrenheit. Pasteurization is basically heating up to a certain temperature with the primary goal of killing microbes. It's also well known and documented that heat in that range also changes protein structure in a generally agreed upon negative fashion. And this little diagram here just shows what happens under the influence of this kind of heat. The protein structure basically unravels. More on protein denaturation. The heating causes protein denaturation or degradation. This is clearly not a positive thing when it comes to protein integrity, usability. Additionally, enzymes responsible for the digestion and breakdown of food are temperature sensitive. Enzymes are composed of protein as well. Heat above 37 degrees centigrade completely destroys enzymes. Step 7. Ultrafiltration process. The remaining protein juice is further purified by ultrafiltration using a 50 or 100 kilodalton molecular weight cutoff membrane system. This consists of pumping the solubilized protein juice under pressure through a membrane filter that separates the components on the basis of their molecular size. This brings the protein concentration up to about 6% in the solution. Step 8. The protein-enriched solution is then continuously diafiltered with 3 parts water per 1 part protein juice. So the protein-enriched solution is then put through this additional process to further concentrate it, ultimately bringing it up to a concentration of about 65%. Step 9. The pH of the solution is adjusted again, this time to 8.3, once again using sodium hydroxide. Step 10. Pasteurization at 85 degrees centigrade, or 185 degrees Fahrenheit. All the same applies as discussed previously regarding high temperatures' impact on proteins. Step 11. Drying with a rotary wheel spray dryer. Once again, this is a generic example of that process. So step 12 is another process that may be applied along the way. Therefore, its location and sequence may vary. Phytate, a storage form of phosphorus that has both negative and positive attributes, is reduced via an enzymatic degradation and incubation process using exogenous phytase added to break down and degrade phytate or phytic acid. Here's a summary of the major steps in the production of pea protein. As you can see, it's a pretty complex multi-step process with the final product very far removed from the food it originally occurred in. Pea protein does not even come close to resembling whole food. Now, let's contrast that with how we make our pumpkin seed protein. Of course, the technique varies somewhat from manufacturer to manufacturer, with some not being as clean or direct as ours. For that reason, and several others, we chose to make the investment in our own equipment and to make it ourselves. Step 1. Organic pumpkin seeds are coarse ground to increase the surface area, thereby making them easier to press. Note that our grinder is only used to grind pumpkin seeds. Therefore, there is no potential for cross-contamination with potential allergens. Step 2. The coarse ground seeds are pressed via a cold press process on a hydraulic press. So it's important that we're using a mechanical hydraulic press via the cold press process that never exceeds 90 degrees Fahrenheit. This is simply to press out most of the oil from the seeds, thereby concentrating its protein content from about 30% to over 65%. This is a picture of the actual press we use. So hydraulic press is the only cold press method. Most companies use an expeller or a screw press and call their process cold, but the friction generates a great deal of heat, in excess of 200 degrees Fahrenheit. We know this for an absolute fact as we bought one of the top expeller presses from a Wisconsin company and had to return it due to the high heat needed to press hold pumpkin seeds successfully, even though we were guaranteed it could do it at room temperature. Didn't work that way. Step 3 in the production of pumpkin seed protein. The pressed pumpkin seed material is ground into a flour-like consistency using a cold milling process. And again, that's a picture of the grinder, only used for this purpose, and the pumpkin seed powder. That's it. Very simple, clean, minimally processed, and kept as close to whole food as possible. Basically, it is real food. Okay, so here's again the side-by-side example showing the steps for pumpkin seed protein and for pea protein. I don't know if I really need to say any more. There's really no comparison as far as which one is the closest to real food. In fact, is real food. Clearly, pumpkin seed protein is the winner by miles. Some people ask the obvious question, why not just eat lots of pumpkin seeds for my protein needs? You can, and I strongly recommend eating lots of pumpkin seeds. I do, but there are a couple of issues as well. First, it can be a bit inconvenient. Next, they will get stuck in your teeth and sometimes injure your gums, just from the mechanical chewing process and the sharp points on them. 3, it can be a bit monotonous. After all, variety is the spice of life. And for while the oil is super healthy, it is calorically dense, so it may not fit the macronutrient profile that a given individual desires. Let's face it, we're all different, with different goals and desires. Some people need to restrict calories, fat, and carbs more than others to achieve the physique and health they want. I'm a huge proponent of getting as many of your nutrients as possible from diet. Food-based nutrition is virtually always the best. There are times, however, when something more or something extra is needed to achieve a certain goal or objective. Making sure that you're getting sufficient amounts of quality, clean, digestible whole food protein is one of those times that it often makes sense to use a supplement. The only truly whole food protein powder made, as you'll learn in future videos in this series, are the ones I developed and use personally from pumpkin seed protein. Remember, I come from a 40-plus year background of working in the trenches of progressive medicine. I trained as both a naturopath and an osteopath, also obtaining a PhD in nutrition. Perhaps more importantly, I'm also an athlete, and I've practiced what I preach in nutrition even longer than I practice medicine. Over the years of medical practice, I prescribed and recommended thousands of supplements to help my patients, yet now I take only a few essentials. All the rest I get from whole superfoods. Pumpkin seeds are one of the world's greatest superfoods. That's why I use them to make our pumpkin seed protein products. Thanks for watching. I hope you learned something new. Please list in the comments what you learned from this. And be sure to subscribe to my channel and keep an eye out for future videos. Take care until next time.